clarify this, okay? So let's start here at the top. It says here, I'm going to, we do this, please? Okay, so the way I do this when I'm teaching people are like, okay? No, there's not. So it says here, from Leah's position in class, she is 6 meters, 20 degrees west to Emily, who is 6 meters north, 35 degrees west to Owen. How far is it from Leah to Owen? All right, now, these questions here, this is going to be a triangular question, so there should be a triangle. What is the first point on my triangle going to be? Go ahead, Leah, okay. So I'm going to start with Leah. So I know how this triangle is going to look because I'm looking at the classroom. So she's going to be over here someplace, and I'll put an L right like that. Okay. All right, so then it says she's 6 meters south 20 degrees west. How do we draw south 20 degrees west? Go ahead.
You draw a dotted line straight down and then draw a line, like a diagonal line to the left, and then that angle is 20 degrees and that line is 6 degrees.
Okay, now, and that's going to be to Emily then. Now I'm going to take a step back to make sure we're good there. Okay. So what happens is when you're going south 20 degrees west, that means you're facing south, and then you're going to spin 20 degrees to the west. Yes?
Are we assuming that Owen is directly west?
No, you never can do that. You never can make that assumption. Okay, it's impossible to make that assumption, right? Because in this case, you have to do the same. In this class, you have to do the same, but in my tilted world, you could be up, you're maybe up 3 centimeters. Like, it'd have to be exactly, you know what I mean? All of a sudden, you're not directly square, okay? All right, so how do I draw the next one here now? So it says, Emily, it's 7 meters north, 35 degrees west to Owen. How do I draw that? Yeah, Owen, go ahead.
Line north and then
That's going to be 7 meters. And that's going to Owen. We're ultimately solving, whoops, I want that, and I ultimately want this to be your x, which is what we're looking for. Are we okay on the idea of that diagram? Oops. I stepped on a girl's foot this morning. I hope I didn't hurt her that badly. Okay, right? I said the same thing there, so sorry. Okay, are we okay on that? Now, what do we actually need to solve this picture now? We still need one last thing. Liam, what do we still need?
angle B.
Yeah, so we have this angle, this green angle here. Okay, that's what we have. We need the entire big angle on the bottom. How can I get the right-hand side of that angle? Yeah, go ahead, Rob. You use that pattern, right? So these are actually parallel lines because north and north. So it goes zzz, 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 and we get 20 degrees. If you don't like Z pattern, which not everyone does, okay, you can also do this. This is another right angle triangle over here. Should make that 70, and then another one is up to be 90 straight up north. So either one of those will work fine there. Okay. Are we okay on why that gets to be 20? Okay. So what does that make the overall middle angle going to be then? 55. Now before you guys are freaking out saying this is impossible, in today's lesson, Leah will be 6 meters in the air, Emily will be 4 meters underground, and Owen will be 100 meters up in the air for this question. Okay, right? So instead of just being like everyone's on a flat level, today we're moving on to the third dimension where there's showing more stuff going on. Okay, so yeah.
I got it like the 20 degrees, but I used like the other, like that triangle.
Yeah, you can use any one you want. I mean, you could have also, if you wanted to, use this triangle up here, right?
That's what I did. I
And
used
that
that
one
one
works.
and the other one.
Right, so the nice thing with these navigation problems, everything's 90 degrees. That's a north, south, east, west. I'm going to redraw this diagram. You don't have to do this, but it's a little easier for me to see if I do it this way. So I'm going to do there's an L, there's an X, there's a 55, there's an E, there's a 7, there's a 6. That's ultimately what we have there. Yeah, go ahead.
And cosine law?
It's going to be cosine law. Can you recite cosine law from memory, please?
X squared plus x squared equals a squared plus b squared minus 2 plus 8.
Close access, have to do that. All right, can somebody else sub in some numbers for me now, please? Krista, go ahead. now before I continue, I'm gonna hit pause in the video. Start yelling. I don't yell, I'm sorry, I yelled yesterday, I felt awful with that. What you all have is to calculate that for me, please. Nicole, can you be brave, please, and give me that answer, if you'd be so kind? Fine, that's just fine, yeah. A little louder? 6.07. Okay, we all agree with that? Yes? Good. So therefore, Leah is 6.07 meters per mole. Yeah, does everyone see why I can't guarantee that's going to be like east-west at the top? Like it might be, right, but you can't make that assumption, right? The only thing we can use is the other angles, right? And please be brave and ask a question with this because we're increasing the difficulty here in a sec here. Is that a question, Hannah? Or no? Just resting your hand. That's good. Yeah?
Which length is A and B?
No. Right, you could have used, 6 plus 7. Whatever. Good? Okay. Any questions from last night's homework on, what's it called? Ambiguous case. Good luck on your test, that's all I'm going to say. All right. Today's lesson is called 3D word problems. I'm going to stop this video.